Hello friends, can you find the sum of nth term for the following sequences? Let's first start with a simple sequence, that is the geometric sequence. So you can find the sum to nth term by using the simple formula, and you can get the result as 1 minus 2 to the power minus n. Let's move further toward a more difficult question. Let's look at this pattern. It's an arithmetico-geometric sequence because the numerator part has an arithmetic progression and the denominator part has the geometric progression. So its nth term is n over 2 to the n minus 1, and maybe in high school you may have studied the sum of nth term of arithmetico-geometric sequence, and you can calculate this and the result seems like this. But what happens when it's more complex than this? Let's see another example. It's what I call is quadratico-geometric sequence because the numerator part consists of the polynomial in n with degree 2, so I usually call it the quadratico-geometric sequence, and it's rather difficult to solve this type of problems. Its answer is like this. And what happens when the numerator part consists of some polynomials in n and the denominator part consists of some ratio, or what I call is polynomial-geometric sequence. So can you find the sum of nth term for these type of sequences? The answer for this question is in this expression. So it's quite hard to do arithmetically, but here I'll use a simple method to do this generalization. So today we are talking about the sum of nth term for the following sequence whose general term can be represented by f of n, where f of n can be any polynomial of n with integral powers in n. Like the power of n has got 1, the power here is n squared, and the power here is n cubed. So it may take any positive integral powers of n in the numerator, and in the denominator the geometric ratio is present in the form of x to the n, where x is not equals to 0, and f of n is any polynomial in n. So let's get started. So before starting, you must have the general concept of series, sum, and finding the general term. And also you need to know the concept of combination because we are going to use the concept of combination to find the general patterns. And also I have already created the idea for finding the sum to infinity, where the sequence is in this form by using a rule which I call the rule of diagonalization. So you can refer that video, which I will be keeping in the description. So it will be very helpful for you to find the sum of the series to infinity, and we will use that rule here to find the sum for nth term. So for the general term Tn equals f of n by x to the n, the sum is given by this formula. I have derived this formula myself, so you cannot find this formula searching in Google. Today I am not going to use this formula, but I am going to use it in a simple way, and I will solve one problem so that you will be clear. So let's start with the problem. I will start with a complex problem so that you will find it easy to do all the simpler problems. So let's start with this problem where the general term is represented by this function. So the first thing we are going to do is finding the term by placing n equals 1, 2, 3 and so on. So that we are going to find the first term, second term, third term and so on. So first we replace n is equal to 1, then we can get the result as 654. Then we put n equals 2 in this equation to get 25 by 4 square. Then we use n equals 3 to get the result as 76 by 4 cube. And also we put t4 to get the result as 177 by 4 to the power of 4. But one question prevails: how many terms do we need to find out the sum for nth term? There is an easy idea for it. We only need one more term than the highest degree in the n in numerator. That means, let's see in the numerator, the highest degree of n is 3, so we need 4 terms to get the result. So we are only finding the fourth terms of the series. after this. So we can write the sum in this form: the first term plus second term, third term, fourth term, plus dot 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 up to nth term. Now we take out the numerators and find differences. To take out the numerator, we first need to search the geometric ratio with power 1. You can look the denominator like it has got 4 to the power 3, 4 to the power 2, 4 to the power 1. So this will be our first term. So we take out the numerator from this term. That means the numerator will be 6, 25, 76 and 177. Then we find the consecutive differences between them. So 25 minus 6 is 19, 76 minus 25 is 51, and 177 minus 76 is 101. So until there's one number left at the last, we are going to find the consecutive differences again and again. So 51 minus 19 is 32, 101 minus 51 is 50, and again 50 minus 32 is 18. So in the next step, we are only going to look at these diagonal elements, that is 6, 19, 32 and 18, and we are going to exclude all other numbers. Then now we use the rule of diagonalization to find the sum to infinity of this series. So before proceeding, I request you to look the video that is given in the link in the description, because we are going to apply that rule over here to find the sum for infinity. So these are the diagonal elements put in the numerator like this: 6, 19, 32 and 18. And since we have got 4 in the denominator, so we subtract 1. So 4 minus 1 will give 3, and we put 3 in the denominator with increasing powers. So by adding these fractions, we will get 149 over 27. And in the next step, what we do is we forgot this first pattern, the first number, we forget the number 6, and we start assuming the geometric series sum starting from 19. So to find the sum to infinity, we get this fraction, we put 19, 32, 18, 19, 32 and 18 in the numerator, since we have already forgotten the number 6, and again we put 3 in the denominator with increasing powers like this, and after simplification we will get this result as 95 by 9. And in the third step, we forget the numbers 19 and 6, and we only look the number 32 and 18 and repeat this process. We put these number 32 and 18 in the numerators, 32 and 18, and we put in the denominator number 3 with increasing powers, that is 3 to the 1 and 3 to the 2, and find this result will be equal to 38 by 3. And in the last step, we forgot all these numbers and we only remain with number 18, and we again repeat this process, that is 18 divided by 3 to get the result as 6. Let's assume these numbers to be A0, A1, A2 and A3. These numbers are nothing but the sum to infinity when all these diagonal elements are taken is considered to be A0. When the first term is neglected, the sum to infinity is given by A1, and when these two terms are neglected, the sum to infinity given by these two numbers only is given by A2, and the sum to infinity with number 18 only is given by A3. Then we multiply with proper combinations. So this number is related with the combination C and 0. Since this is the 0th sum to infinity, and in the second term here's 1, so we multiply with C and 1, and similarly we multiply with the combination of n taken out 2 at a time, and we multiply it with C and 3. Then the general term for the sum of nth term is given by the relation like this. So don't be afraid of looking at this equation, it's quite easy. So this number 149 by 27 is the number that we got here, 149 by 27, and minus is a compulsory, and we put here 1 over 4 to the n. 4 to the n is nothing but simply this denominator, that is 4 to the n, and we multiply this whole number with the sum of these all numbers. So 149 by 27 times cn0, this is the number, plus this whole number, plus these whole numbers, and plus this whole number. So this will be the general term for sum of nth term of the series. So let's simplify this result. Since the combination of n taken 0 at a time is 1, and cn1 can be taken as n, cn2 is nothing but n times n minus 1 by 2, and cn3 it can be written as n times n minus 1 times n minus 2 by 3 factorial, or 6. So by simplifying this, we will get this result, and finally we will reach to this equation. Now let's check the result. Let's find out the sum for first term of the series. This will be equal to 6 by 4. For the second sum, that will be equal to 6 by 4 plus 25 by 4 squared, which is 49 by 16. For the third sum, it will be equal to the sum of these three terms, which will be 17 by 4. And for the sum for fourth terms, these four terms will be added to get 1265 by 256. Now let's use the equation to check our result. Let's put n equals 1 over here. Then we will get 654, which is the same result. Let's put n equals 2, we will get 49 by 16. Let's put n equals 3, we will get 17 by 4. And let's put n equals 4, we will get the same result. So this summation is correctly defined by this equation. So after knowing this complex problem, so can you try the more simpler problems like this? And if you have any problem regarding these problems, please leave in the comments below. And thanks for watching.